So in this lecture, I want to go into a bunch of examples of data visualization projects or visualization generally. Depends on what counts as data, I suppose. I'm not going to go too in depth into the theory. That's just not what this course is aligned to. There is a huge amount of theory that's possible, but my goal is to just crack open the space of possibility so that you can see a huge number of examples. And then from those examples, you'll have the opportunity to, in your future career, to think about them and think, okay, this is possible. There is some way to do something like this or that. And you'll be able to work from there. So, have a little bit of a starting point. So data visualization is the representation of data through use of common graphics such as charts, plots, infographics, and even animations. These visual displays of information communicate complex data relationships and data-driven insights in a way that is easy to understand. And so like that's part of the point of visualization is, a picture paints 1,000 words, or it's worth 1,000 words. And yeah, this comes from IBM. So here is just a really classic data visualization. It's a word cloud. You can go to wordclouds.com, put in a bunch of words, or and it'll make a cloud for you. Um, I am somewhat skeptical on how useful these things are, but I mean they do show something, which is like the prominence of particular words relative to others. Other visualizations, so charts and plots, and they can, yeah, they relay information quickly and effectively. So you have your bar charts, you have your pie charts, you have your, stock market plots or graphs. Um, there's a bunch of things that you have to be a little bit concerned about here, especially if you're dealing with plots. It's like where is the X and Y axis? So like you can notice here, the vertical axis starts at 125 and goes up to 275. So this looks like really dramatic movement, but it's, might not actually be as dramatic if you actually started from zero. There's lots of ways to mislead with graphs. We're not going to go into that, but yeah, there are concerns and considerations here. Uh, Another type of visualization. Yeah, this is an example of a graph. We'll get into more depth later, but this is from a service called Connected Papers. And what you do is you enter the DOI of a journal article, some sort of typical paper, and Connected Papers builds a graph of similar papers in the field, usually based off of citations, though not always. So yeah, so it'll see a bunch of things that it cites, and it'll see a bunch of things that cites it, and you can kind of you can make family trees of sorts, or you can make just webs of influence or similarity. And really easy way to play around with network visualization. Bunch of other examples here. So Kurt Vonnegut devised something he called story shapes, which display various plot structures. So, for example, there's the man in the hole story structure. There's the main character gets into trouble, then gets out of it again, and ends up, a little bit better off for their experience. Or there's the boy meets girl, or from bad to worse. Kafka's metamorphosis. Just main character starts off poorly and then just gets continually worse with no hope for improvement. Um, and there's a bunch of other story shapes. One of his insights is that the New Testament is actually a Cinderella story shape, which is kind of interesting. Anyways, so he also thinks that it's possible for a story to be both a man in the hole and an overcoming the monster story as examples. You can have many different story shapes kind of overlaid with each other. And again, these shapes are visualizations of the structure of the narrative that is happening. So continuing on with that theme, so perhaps the most famous plot structure is Joseph Campbell's The Monomyth or The Hero's Journey. So he describes the narrative pattern as follows. A hero ventures forth from the world of the common day into a region of the supernatural wonder. Fabulous forces are there encountered, and a decisive victory is won. And the hero comes back from this mysterious adventure with a power to bestow boons on his fellow man. And I mean, this story structure is fairly easy. It's a circle. It's just there's particular points along the way. And as a visualization of what a story looks like, I mean that it tells you something. You can kind of figure out where you are on that journey. So yeah, there's a lot of different types of visualizations. We talked briefly about charts and plots and like bar graphs, what have you. There's a lot there. I'm skipping a lot of that. Maps are another important type of visualization. We'll get to that next week. So for the rest of this lecture, I'm going to focus on two types of visualizations, graphs and timelines. So let's talk about influence graphs. There's a lot of ways to think about influence. I think it's the most generic word that I could use because you can have like inheritance, you could have just uh, temporal succession, you can have a bunch of different things. And we're not trying to be biased towards one way or another at this point. So here's two examples of simple graphs. So the first one here is a simple graph of 6 nodes and 7 undirected edges. There's no directionality to these edges, the lines between the circles. Those edges are just saying there's some connection. Oftentimes, though, there's some directionality. So the second example here's a graph with 3 nodes and 4 directed edges. The double arrow represents an edge in each direction. I'm not sure if you can see that underneath my picture, but yeah, the each time an arrow points in a direction, that's an edge going that way. You could also think of it as one edge that's bidirectional, but this one is set up so that you would think about it as two separate edges that just are overlapping, two directional edges that are overlapping. And yeah, you can set up a bunch of different things with this. So this is the first one here is the Manhattan Project's collaboration network. So all the different people who worked on the Manhattan Project that worked with each other, published things with each other, and yeah, you can see there's quite a lot of influence between these people. You can see Niels Bohr, Enrico Fermi, Oppenheimer, um, Edward Teller. Some of these names probably not as familiar to you unless you've actually like gone into that domain. Leo Szilard. Anyways, try not to get too interested. And then a similar-ish example is the Nobel Laureate Collaboration Network. So these are each node is a person who won a Nobel Prize, and each edge is a connection between that person and another person who won a Nobel Prize. And you can see, well, Einstein's circle is pretty big. A lot of people collaborated with him, and there's, people who form bridges between other nodes of cooperation, and but who would otherwise, those groupings would otherwise be unconnected, which is, I think, kind of interesting. So Marie Curie right there is an example because she's a person who won Nobel Prizes in both physics and chemistry. All right, moving on. And you can have nodes and edges in a lot of interesting ways. So this is a proposed model of textual inheritance, including the hypothetical Q source in the Bible. So if you look at the first 3 books of the Bible, they're called the Synoptic Gospels. John's weird and does its own thing. You can notice that a lot of the material in Matthew and a lot of the material in Mark, or in Luke, come from Mark. But they also have stuff in common that seems to come from somewhere else. And that common inheritance that doesn't come from Mark implies some other source of that common material. And that hypothetical source is called Q. This becomes easy to see at a glance as a possibility when you have a visualization like this. And of course, Matthew and Luke have material that's unique to each of them. So you can really use these influence graphs to depict very diverse types of information. Here's another example. This is a diagram from a paper called Computer-Aided Schematics, a case of 52 versions of it's a Hindu holy book that I'm not going to be able to pronounce well. But anyways, there's like 52 different versions of this book with different scribal differences between them, paragraph added here, paragraph lost there, things like that. And the mass was able to construct essentially a family tree of, okay, we see what the earliest version is, we see how the different versions were descended from that, how some later scribes took multiple different copies and combined them into later versions that incorporated a bunch of those different differences. And yeah, you can see again at a glance that there's been a lot of evolution of these particular texts, which I think is neat. Oh, and we can keep going. So, the phylogeny of Little Red Riding Hood, which features, different clades and geographic distributions. So you can see that there are many stories that fit the Uther RNA Thompson index. Thompson Uther RNA index, whatever. I don't remember the order of fairy tale motifs. And they say, okay, there's a bunch of stories around the world that have similar structure, that have common qualities to them. And you can put them on a graph and notice how, well, if you go back in time and back in location, you can kind of track the diffusion of this story structure across the world and across time. And you can notice that there are African variants of it and East Asian variants of it, and at least a couple of European versions. And the oldest attested version seems to come out of India, though the Aesop fables are not too far behind. And that's kind of an interesting way of suggesting that at least some versions of this story. You can imagine that like unique independent genesis happen of a similar story, but a lot of them might actually just be tellings and retellings and retellings of the same story again and again across the world. And you can just keep on going with this idea. So this is one of my favorite examples. This is the cosmic hunt. It's a type of story shared by many cultures around the world, often involving the Big Dipper, so the Ursa Major, the constellation. The details of these stories suggest a shared origin from before the closing of the Bering Land Bridge between Asia and North America 15,000 years ago. Like that's one of the things that we can like display to visualize on a network graph like this is to say, okay, there are versions of the cosmic hunt story, which is usually like there's a hunter chasing after some large animal. They try to, throw something at it, some sort of weapon, and the animal escapes up into the sky and becomes the constellation. There's a bunch of other details that are preserved over apparently 10, 15,000 years that would be like unlikely to happen by chance. And so that tells you that these things are actually like connected to each other. And yeah, you can also like notice that there are like languages on either side of the Bering Strait that are clearly related to each other. Anyway, it's fascinating. You can like build up layers upon layers of evidence, and you can demonstrate, you can display that connection in a graph like this. And you say, okay, um, we can see the different versions of the story in Cherokee and Mi'kmaq and Seneca peoples, and then you can see other versions of that story in Ovid in Greece and other places. This particular version of the graph doesn't include it, but I happen to know that there are also extensions of it that include some North African stories. So that's like a huge swath of the planet that has some variant of this story that seems to go back into very deep time. Um, and there are more besides, but I just really like this one. Other examples. So genres can be seen as sitting in relationships to each other. You have, um, an older genre, and it gives rise to daughter genres that have lots in common, but are differentiated in other ways. And you can display again all of these connections on a graph. So genres often start around a thing or a collection of things, like a visual motif or a style of story, as in the case of film noir, for example, or a specific technique, like in dubstep music. But as time goes on, more and more new art comes out, and the distance between the core style and the fringes gets wider and wider. And eventually, the definition gets so big that the definition just isn't that useful anymore. And so it subdivides. Um, and that's kind of how genres emerge. It's like, well, this like what counts as rock anymore? I don't know. Like almost everything does. And so you have tons of different smaller versions of it, or more detailed articulations. And and then the process just continues. It's kind of like speciation. And the network graph can display some of that history. Yeah, for music, so this is a reproduction of Jack Black's Spider Diagram from School of Rock, which is a movie from a while ago. Um, Kinase Records, which plots, yeah, reproduced by Kinase Records, which plots the relationships between musical genres. Each musical style is encased in its own box, and arrows connecting them, each arrow indicating the influence of one genre upon the other. So we got our nodes, we got our edges, and alongside the nodes, we have a bunch of examples of what might count as that particular genre. Um, yeah, and it's really quite interesting. Like you can notice, like blues having such a huge early influence on so much of what came afterwards. Now, obviously, this is going to be somewhat American centric, but still fairly interesting. My final example is at least of the network graphs, is the timeline of tabletop role-playing games by Pascal Martinoli. It describes the relationships between different role-playing games, highlighted by some particular innovations that separate them. So up here in the middle, in the top, we have Dungeons and Dragons second edition, I think they called it Advanced D&D. And you can see a bunch of the different particular innovations that accompanied those things. Innovations in sort of like, again, like a biological species sense, mutations. They're not necessarily good or bad, they're just changes from what came before. And you can see from that a whole lot of other things gained were inspired by it. And the edges, which, a little bit wavy in this case, point to those later works that again had inspiration from it. One of the things I really like about this example is that many of the edges are have they're not just directional, but they are typed. They tell you the type of influence that they have, or at least the type of innovation that came along with that influence. All right. Now I'm also going to describe timelines because I think they're another type of visualization that I won't cover otherwise. So this is probably one of the most classic ones, the carte figurative. It is Napoleon's invasion of Russia. So the thickness of the line is the size of the army, Napoleon's army. This was like 1812. Yeah, there's the date right there. 1812 to 1813. And yeah, he had a massive army as he was going to invade Russia. You can see Moscow right there. And it just started dwindling a lot and a lot and a lot. And very few of those people who started off ended up coming back. Um, and that's, once you know what the thickness of the line means, so the kind of beige color means we're invading, the black color means we're retreating. And and you can look in it and see, okay, I can see some of the place names, I can see some of the numbers. And even though, like we can imagine we don't speak French, we can still like get a lot out of this, which I think is cool. Other things you might be able to do. This is from a YouTube video, I believe, screenshot of their title card. So this is the timeline of Canadian political parties. I think and yeah, it shows us like the line that's at the top is the line that is represents the color or the party, I should say, of that's in power in the government at that time. So one of the things you can notice pretty quickly is that the Liberals have been in charge more often than any other party, though the Conservatives are certainly number two there. You can see the NDP. If you go back a little bit further, the NDP only really became a thing in like the 60s or something like that. They came out of this. I wouldn't want to say they would come out of the Social Credit Party, but anyways, um, there's some common lineage there. But yeah, there was a time, and many of you probably remember it, wherein the NDP overtook the Liberals as the second party, and that was just interesting situation. You can see the merger of the PC Party and the Reform Party, which are not actually all that closely aligned ideologically. They're just more closely aligned than any of the other major parties, and so it's actually one of the big problems with the conservatives right now is that like they have this Western autonomy wing that they want to go off and do their own thing up to possibly independence. And then they have the, more classic progressive conservative wing, and they don't always get along. Um, anyway, so this timeline shows a lot of that history really, really quite concisely. If you take the time to just notice what it's doing. More information possibly could have been put into it, but I don't know. Sometimes you don't want to overload things. All right. Other sorts of timelines. So this is the table of contents, the first one here from Asimov's Chronology of Science and Discovery. And he just made a line and put on it all the things that he thought were important discoveries and scientific innovations. So you could look back 600 BC, water identified as an element. So he thought like Thales and the idea that water is an element was an important consideration. It's like some undividable substance that helps that other things are built out of. And yeah, that's an important idea, even if like the details of it turned out to be wrong. Because later we had the idea of atoms, and then he includes coffee. I mean, it might say something about him there, but arguably that it was an important innovation. And then yeah, you can just keep on going and seeing the things, and that's how he divvies up history. So the Chinese navigating the Indian Ocean, things like that. A I would say perhaps more scholarly attempt to do something similar is Kevin Sharp's History of Western Philosophy from 600 BC to 600 CE. At least that's what this one's from. And the ovals, the elongated ovals, those are the lifespans, or at least the productivity spans of individual people, and the lines the dots within those are particular works or expressions or instances of their intellectual effort, and then the lines are again lines of influence. So this is kind of a timeline and a graph overlaid on each other. And again, this is probably most useful for someone who's already familiar with the subject matter, but it can also be an interesting introduction to see like how did all of these figures relate to each other. Another example. If we're going to do timelines, we're going to have to do at least a little bit of time travel. Again, I think this one might be from a screenshot from a YouTube video. I've never seen this one though, so I can't say for sure. But yeah, here's Groundhog Day. Here's what the timeline looks like. Here's Harry Potter. Well, it only has time travel once apparently. Um, Christmas Carol, Back to the Future, Primer. Yeah, Primer's very confusing. Um, I don't know. I think this one's a little simplistic, so I want to end with just one more. If we're going to talk about time travel, let's do the original, well, not the original, but perhaps the most influential one in the past, 40 years, Back to the Future. So this is the Back to the Future timeline, and you can see where things start up here at the start, and it lists when things happen. The very first thing, the dog is sent into the future by 1 minute, and then everything that follows after that. Um, there are some questions because the movie has plot holes, but yeah, I don't know if you're a fan of that piece of media, um, it is a fun depiction of what happened in that movie. Anyways, I just enjoyed going through a bunch of examples of data visualization with you, and I hope that you enjoyed some of that. All right.